Calculus has pushed me to my limit. Goodbye, cruel world.
What you say? That you only meant well, 'cause you did. What you say?
Okay, so first we have 4 reasons why limits do not exist. The first one is the function approaches a different number from the left than from the right. The second one is if a function increases or decreases without bounds, so if it would go to positive infinity or negative infinity. The function oscillates between 2 fixed values like a sine function, and if you cannot approach from one side or the other. And so these would be when you would evaluate a limit, but then you would be able to determine that the general limit does not exist.
Reasons they don't exist. Don't listen to him. Huh. He doesn't exist now.
So, limits by direct substitution. There are 4 times you can directly substitute the value that x is approaching into the function, and that is when f of x is a polynomial, when f of x is a rational function and f of a is defined, when f of x is a trig function and f of a is defined, and when f of x is a radical function and when f of a is defined, and when a is not the endpoint of the function.
What you say? That you only meant well.
Evaluate a limit at x equals a. Substitute a for x in the function. If you get a number, then that is the limit. If you get 0 over 0, then there is a limit to be found. Use methods of factoring, common denominators, or the method of conjugate multiplication. If you get non-zero over 0, then the limit does not exist, but you may be able to use infinity or negative infinity to be determined by inspection.
What you say?
When you're evaluating an infinite limit, first try direct substitution. If the f of x evaluates to non-zero over 0, then the limit does not exist, but it may be better described as positive or negative infinity. And so to find out if it's positive or negative infinity, you should choose an appropriate number close to the a or the x and determine the signs of the numerator and denominator. If the signs are alike, the limit is infinity. If the signs are different, the limit will be negative infinity.
What you say?
Finding a limit at infinity of a rational function. If the degrees of the numerator and denominator are the same, then the limit is the ratio of the leading coefficients, the coefficients of the terms of the highest degree. If the degree of the denominator is higher than the degree of the numerator, then the limit is 0. If the degree of the numerator is higher, then the limit is either infinity or negative infinity, which can be determined by inspection, by examining the signs of the terms of highest degree.
Hello, we are the exponents of the leading coefficient.
Hello, I'm the quotient of the leading coefficient. Whoa, that's crazy. The exponent on the top is lower than that at the bottom, so I guess I'm the limit now.
Whoa, the exponent on top is higher than the one on the bottom now, so I guess I'm infinity. I just want you guys to know for once I'm not getting hurt, so I am just,
What you say? That you only meant well, 'cause you did what you say. That is no one told you life was gonna be this way. Your job's a joke you broke, your love life's the away. It's like you're always stuck in second gear, when it hasn't been your day, your week, your month, or even your year. But I'll be there for you when the rain starts to fall. I'll be there for you. I'll be there for you, 'cause you're there for me too. You're still in bed at 10 and we're
Whoa! Who are you who can summon fire with their hands?
I'm the enchanter.